Here's something that you've probably heard in the news, maybe once or twice in the last 4 or 5 years. We're going to turn our attention to Texas high-speed train. Some people call it the bullet train. It's got to be the biggest infrastructure project to happen in decades, I would think, since DFW Airport was created. And momentum is building toward construction of this massive project. So today we have 2 members of Texas Central's leadership team join us for the discussion. We're going to have a conversational type thing this afternoon. I've got some slides to show you as well. Unfortunately, there's one person who was on the agenda that could be here today, Carlos Aguilar, who is the president and CEO of Texas Central. He was called away for a very important meeting in Japan. So we give him his allowance for that.
I'm not Carlos Aguilar, sorry.
And
Norma.
No, okay. Now that we've gotten that straight. Holly Reed, which Holly to my left, she serves as Texas Central's Managing Director of External Affairs and brings to the role some very extensive experience communicating benefits of large-scale infrastructure projects like fiber optic networks and the Texas high-speed train. And she manages complexity, bringing first-of-its-kind technologies to consumers. And to my right is Paul Waby. He is Texas Central's Rail System Director, also joining us today. Paul is one of the world's foremost experts on the Shinkansen trains that are running at 200 miles an hour in Texas. Paul has more than 27 years experience in the rail industry and is part of the team that delivered the Taiwan high-speed rail, which opened in 2007, the only other Shinkansen export project in the world. I want to thank you both for joining us today to talk about the Texas high-speed train. And if we have a little trouble understanding Paul, give him a little allowance. He's from the UK, so
I'm slowly learning the
Texas lingo.
How to say y'all? Yes.
Y'all?
Yeah.
It's y'all.
Y'all.
You'll get it. Don't.
Y'all.
You're fine. You're doing great. Okay. Well, in addition to the brief discussion I provided, I want to ask each of you to begin by sharing with our audience this afternoon the reason why you decided to get into this thing, the high-speed train project, how long you've been involved in it. So Holly, give us a little bit of background on you.
Sure. So never thought I'd be building a railroad. We'll start there. I had a 25-year career at AT&T and worked on a lot of different projects, a lot of different parts of that business, everything from the call center to IT, strategic planning, things of that nature. But also most of my time there was working with communities, state, local, on public policy issues and on community involvement issues. And you may not think that railroads and telecommunications intersect, but when you think about the fact that they're both linear infrastructure, they're both connecting people, they're driving the speed of commerce. When we deploy both fiber optics and we deployed the mobile network, and I'm dating myself, but I was there for both of those. You know, everybody wants their phone to work, nobody wants a tower in their backyard. It's very similar. We dug up everybody's front yard, fiber optics in there. How do you do that and communicate the benefits of that so that people, customers will stick with you and understand that a little bit of the disruption during construction is worth what the benefits are on the back end. And so, well, it doesn't seem like they're similar, they actually are. Still, I never thought I would leave. Nobody ever leaves the firm. I never thought I would leave. But for the fact that this is a once-in-a-lifetime opportunity to do something important and to save lives, put a lot of people to work, and transform how Texans and Americans think about traveling. And that was a great opportunity. And I've been there for 4 years now, and very pleased that we've come a long way from oftentimes, is it really going to happen, to when can I ride it?
All right. Paul, we found out we have a connection because we like the same fish and chip shops in Whitby, England. But,
That's true.
Other than that, you tell us a little bit about your background.
So I'm lucky enough when I graduated college to go straight into a job with then Westinghouse Signals, a rail signaling company in the southwest of England. And about a year after I graduated, they put me on a plane to China, told me please go and help our China project for 3 weeks. 9 years later, one wife, 2 children later, I emerged out of China having built 2 metros, and I kind of caught the nerdy railway bug. And I've been building railways ever since, mainly in Asia, in China, in Taiwan, and Singapore, Hong Kong. Also in London, I worked a considerable length of time for London Underground. I worked for Alstom. I've worked on ECS projects. But I was part of the team that built Taiwan, the other high-speed, the other Shinkansen system. And that was a great project, but it wasn't as good as it could have been. And when I got the call about 2 years ago, and it was 2 years ago, I've been here for 2 years, I wouldn't be kidding when I would say, I said to my wife, there's a guy on the phone from Texas who says they're going to build a Japanese high-speed train. And my wife said, no, it's a crank call, this is, put the phone down. So I put the phone down, and this guy then called me back, and I met him, and we came out, and just purely the opportunity. I mean, the system in Taiwan is fantastic, and it's one of the safest railways in the world, same level of safety as the Japanese system in Tokyo. But the opportunity to do it even better, and to have part of my name on the footprint of potentially the first high-speed rail system in America, who could turn down that opportunity as a railway engineer? Who could? I mean, this is not just about groundbreaking for the US, but, I'm really hoping I get my own Wikipedia page out of this. If anyone wants to write it for me. So there was no way that given the opportunity, I had the opportunity to go and work on HS2. This all came in. We did some talking, spoken to the Japanese. I know them very well. I'd worked with them before. So absolutely, no hesitation to just get on a plane and come to us.
We're glad to have you here. Well, Holly, everyone here is really excited about all the progress that's being made the last few years in pushing the project forward. How's it going? What's next? Most importantly, when are we going to get to ride this train?
The question everybody wants to know the answer to. So yes, we've had an incredible run of milestones that we've achieved, announcements that we've made, all in preparation for getting to construction so that we can get you on the train going 200 miles an hour to Houston in just about an hour and a half. Where we are today is as a result of those partnerships and those announcements and bringing those team members on board, and yes, all railroad humor is allowed on board. We have really refined all the information that is necessary to go into construction. The real timeline management piece of this is a result of the 2 federal approvals that we require to get going. You may recall that we got a draft environmental impact statement in December of 2017. We're working towards the final and the environmental approval, which hopefully we will get this summer. And then the other approval that we need is a rule of particular applicability, the safety regulations for this system and this project. And we need that rule of particular applicability because we are different than any other passenger railway system. We have no at-grade crossings. Nobody else is going 200 miles an hour. It's a dedicated right-of-way, a dedicated system. So that lends itself to a rule of particular applicability. We believe that we are on track for both of the approvals to come in this summer. And I would never make promises on behalf of the FRA or the federal government, but if those timelines do hold, we will be in position to go to start construction shortly thereafter. It'll be a 5 to 6 year construction period. We'll work on all 240 miles currently, so that with that timeline you should be able to ride the train in 2026. So that's kind of where we stand. We've made announcements about our civil infrastructure leads, our technology leads. Our latest announcement was that Mass Electric, a subsidiary of Kiewit, will be doing the installation. Renfe is our operating partner, and then MUFG and Citigroup is the lead with our financial advisors. All of it being program managed by Bechtel. And so all of the subject matter experts in place, and again, being an investor-owned project and not a government-run project, the data and the fiscal discipline of the free market driving timeline schedules and puts us into a schedule to ride it in 2026.
Well, I know you said you're not going to accept any out or operating costs from either the state or federal government. So the billion-dollar question is, how is this thing going to be financed?
Sure. So how do you pay for all those? Well, if you look out on the global stage, and we've got lots of different third-party clips that show there is infrastructure investment looking for a place to go on the global stage. And I think pre-COVID had the number at over $200 billion of dry powder looking for a place to go. And frankly, they want a place to invest in the United States to diversify portfolio from hedge funds, sovereign wealth funds, pension funds, places like that. So we are comfortable that we will be able to get that investment both on the equity and on the debt side to do that. And that is why having those partners on board early with good cost and schedule data allows us to have those conversations the first half of this year in anticipation of getting those federal approvals.
Well, you have some world-class partners that you've got on board too. And looking at the screen here, I mean, it's going to create 10,000 direct jobs. This is just amazing for the state of Texas. This is a massive project.
Yeah, frankly, the workforce component of this is one of the things that keeps us up at night and worries us. With low unemployment figures, we've got to be thinking about this now, and we are. We're already talking with ISPs, with community colleges, with universities, with workforce commissions to make sure that that pipeline is in place so that during peak construction we have the talent and the skill and the folks to build this. Interestingly, I hope that we become a catalyst for workers that might not think they want to go into some of these professions, but get excited about working on the first high-speed train, and therefore when they come to work on this project, they can then work on things like, port terminals and other major construction projects that are in play. And so we're working every single day to do that. And then we will have this new high-speed train industry right here in Texas, and you see the numbers on the screen, 1,500 direct jobs, and people will come from around the world, around the country, of course to ride the train, but also to see how you guys do that, and how can we then take this catalyst into other city pairs to build as well. And so we're excited about that opportunity.
Paul, you were talking earlier about deploying the Shinkansen to Taiwan, and now you're here in Texas. Why will this train system work well here?
I think we have to look back on the experiences from Taiwan. I mean, that was the first time Shinkansen had been exported. The Japanese suppliers were getting used to international methods and standards and best practice. Interestingly, the specifications of Taiwan were written by Americans and British and German and French engineers. And strangely enough, the Taiwan project was contracted under New York state law, which is an interesting fact. And Shinkansen was the right choice for Taiwan because obviously Taiwan, being on the Pacific plate, shares some of the seismic problems that Japan suffers. So they learned a great deal about delivery outside of Japan, especially in delivering in an international way. So many of these Japanese suppliers post-Taiwan went on to deliver railways around the world. Why will it work in Texas? I mean, that's a good question. The obvious and a bit silly answer to that question is the rules of physics still apply in Texas. The brakes, the way the vehicle works, the train performance, those things we can rely on. But being a little bit more serious, there are some differences. The extreme weather conditions in Texas are somewhat similar to Japan. If you look at the humidity in Houston, for example, it's very similar with Hamamatsu in southern Japan and Kyushu Island. Japan suffers 6 to 8 direct typhoon hits a year. They've built the system to withstand some of that. We can't operate in a hurricane or a typhoon, clearly, but the system will survive. Obviously, the custom-built tracks, dedicated alignment, no grade crossings. These are the things that Shinkansen needs to operate safely. The other thing people don't always understand is we're not just buying some boxes and installing them. We're actually importing the whole maintenance and operation philosophy of the Japanese. And people have said to me in the past, oh, that's difficult. You can't get, culturally, you can't get American engineers to behave in the same way as Japanese engineers, for example. Worried about that in Taiwan, but we managed to import that kind of safety culture and operational culture, which was great. I think the clear differences and the areas we're really focused are on some of the other weather and environmental concerns. So, you know, I'm British and hence don't go out in the midday sun. But North Texas, to me, is incredibly hot. I mean, the upper temperatures here, 105, 115 degrees, numbers I don't really understand. I like to think of it in terms of 40 to 45 degrees. That is something that Shinkansen, we're having to analyze every element of each part of the train, the wayside equipment, the communication subsystem, the power. The OCS, for example, the OCS carries the traction power to the train, to the pantograph, and it heats up because it's drawing a lot of current. And the ambient temperature that during that current draw is also pretty critical. So we've had to go through and look at that. The track itself, we're having to look at the neutral point of the track, so that, because obviously in these types of hotter climates, the track is more prone to buckling, especially with the temperature variations we can see here. So we're having to do specific engineering activities and work on elements of it. So I think the only thing I would say is an unknown. It's not quite true. I mean, I think tornadoes are something that they do get in Japan much less frequently. And, you know, all of us in this know it's impossible to completely protect all of your infrastructure from a tornado. You can protect parts of it, you can protect elements of it, but you can't protect all of it. So there are elements of the infrastructure protecting. The General Control Center, which is our kind of NASA-like building that houses our operations team, will be built to withstand large category tornadoes. But the signals and poles and antennas and things on the wayside, we're having to look at methods like, obviously we're building our own meteorological monitoring system along the alignment, wind, rain, radar, rainfall, temperature, rail temperature, ambient temperature, those sorts of things. And we'll buy in professional services to look at tornado likelihood and other things. But that's one area where I think we have to learn to operate around and learn to understand, you know, what elements of the job need to be engineered in a slightly different way. So this is a railway that's been operating in some form in Japan for 50 plus years. I'm not worried about bringing it to the Texas environment, to be honest.
Well, what are you going to do about current armadillos that run across the tracks?
So it's a very interesting point. Not just armadillos. During our risk assessment, we obviously do preliminary hazard analysis, and one of the hazards that came up were these somewhat mystical 250-pound wild-toothed boars, apparently, that roam Texas. Now, obviously, we're setting our alignment with fencing. Much of our alignment is on raised viaducts, so it will be less susceptible. But obviously, a 500-ton train going at almost 200 miles an hour and a 200-pound boar, there isn't much competition in that. There are a lot of pork chops that come out of it, but there is a huge amount of competition. Obviously, it would damage the train, and obviously we have to provide protection and risk assessments. But again, wild animals exist in every country with high-speed rail. We hit cows in the UK pretty regularly, not every day, of course, but somewhat regularly. So we will do what's necessary under a formal risk assessment method to build in the necessary protection systems for that type of event.
Paul, let me stick with you again for just a moment here. Let me bring up a new slide on the screen, if I can. There we go. You're going to have to customize this train a little bit for us here in Texas because, the size and shape of the average Texan's a little bit different from
that was my
actually. Person. Okay. Stole your thunder, sorry.
So one thing I should say to you this now today are the first people outside of Texas Central to see the layout on a train like this.
Ooh.
It's never been shown publicly before. We're going for a 2-2 configuration in standard class, and the reason for that, as you said, is partly because we need to account for the average size of the average Texan, shoulder width I'm talking about.
Yeah.
Definitely shoulders. Shoulders.
But more importantly than that, one of the things that we decided to do from the beginning was to make this a system that would be kind of ground up compliant with the ADA community. So that wider aisle you can see on the train is for obviously wheelchair access. The toilets, those you can see the toilets at the end of, there are 4 of them, those ADA compliant toilets. They have them in Japan, but not as frequently. Pitch, the 41-inch pitch layout between the seats. I mean, if anybody's ever traveled on Southwest, where I think the pitch is currently at 31 or 30 inches, even in standard class, you're going to have a huge amount of space in front of your knees. There's a lot of room, enough room to get in a service animal or something like that. And of course, the other modifications we need to make, there are certain safety requirements from the FRA and things that we have to ensure that our train has. So the emergency windows have been changed slightly, and the number of safety devices that are standard under the FRA regulations, we've had to make allowances for that equipment on the train. We've got passenger alarms on the train that you can push. So we've changed the interior to suit exactly what we believe needed in Texas. The way it works is, although we can see this design today, about a year from now, a mock-up, a kind of half-size, well, a full-size but half-length passenger cabin of both standard and premium class will come to Texas, and we'll invite interest groups in and talk about materials and finish and color and other things. Those decisions are later, but the basic layout, this is the first time it's been seen in public. It's an 8-car configuration, not a 16-car configuration like Japan, but that's pretty normal. There are 8-car variants in Japan of N700s. I mean, this is the S, this is the new train. It doesn't go into passenger service in Japan until the 1st of July, ready for the Summer Olympics. Yeah, it's a beautiful train.
So we'll have the latest, greatest version.
Yes, we will have the latest and the greatest version.
Very good. Holly, currently, and we touched a little bit about this before, no one in Texas gets a degree in high-speed rail train operations. I mean, you're starting from scratch on this. How exactly can you develop this type of workforce?
Well, it has to be intentional.
Yeah.
And I mentioned the different groups that we're already in communications with. The groups that I didn't talk about are groups like the workforce solutions groups, as well as the nonprofit communities. There are a lot of nonprofits that want to help with programs that ensure that pipeline ends up in a job, not just a degree or a certification. And so we will have the jobs on the back end, and we are actually driving some of the conversations around what kind of training will happen in that intersection of workforce, education, and nonprofit communities to make sure that we get the best of the best. Again, I said you have to be intentional about it. You do. Our board of directors actually has approved a program making sure that we're intentional, not only about the workforce side of this, but about how we do procurement when we're ready to do that, and make sure that we have opportunities not only for minority and women-owned businesses, but veteran-owned businesses and rural-owned businesses along alignment, so that those benefits stay not only here, but this project is big enough that you will see an impact across the state of Texas, across the country, and in many instances across the globe. And so while we are an investor, not a government project, we are making sure that we have those positive impacts across all of the different communities, and we will be monitoring and reporting on that. So it is important that we get this right. Again, we take that responsibility very, very deeply into our corporate culture to make sure that when this is a catalyst for other projects or other legs of the that it's done right, and they have something to look at as an example of how to do this. You know, there is no supply chain. There is no workforce. So being first is hard. You know, the reason it's never been done before, it's complicated. You were talking about the different folks that are working on this today. Somebody is uncomfortable on our calls every day because Tokyo, Italy, Spain, Texas, in some instances the UK, there's not a good time to have a conversation. So somebody's uncomfortable or sleepy. And that's what it takes to do the knowledge transfer to build that community of workers here. And there will be programs like Train the Trainer. And there will be all of, we'll have those simulators and all of those things will be in place so that when this is up and running and people fall in love with it, which we know they will, then replicating it is not as difficult or expensive to do it again.
Well, we're talking about a lot of job opportunities and apparently good paying jobs as well. Let's talk a little bit about the economic development that can occur both in Houston and in Dallas. I mean, if you look at where the terminals are going to be, there's probably some really ripe areas for development. I don't want to say that the areas are run down or anything, but there's some opportunities there to really build up and increase the opportunity, the economic opportunity base in both cities.
Yes, so each of the 3 station locations has a unique personality, we'll just say that.
Yeah.
The station location here in the North Texas area is just outside of downtown Dallas. So in the Cedars neighborhood, just south of I-30, you'll be able to walk to the convention center. You'll be able to connect art, whether it's at the convention center or the Cedars station. And we will be planning in each of the locations parking garages, ride share, rental cars, all of those kinds of things. Also with the understanding of the data of how much parking will we actually need. You've heard people talk earlier about the changing demographics of how people get around and how they drive or if they drive. We're looking at all of that data as well. So that neighborhood is actually already, I think, developing in ways taking that future station into consideration in the Dallas area. In Grimes County in the Brazos Valley, it's a greenfield. We're at the intersection of Highway 9 and Highway 30, and that will transform that area. And it will be interesting to see what the traffic pattern, ridership patterns for the train are, because we're about equal distance between College Station and Huntsville. It'll be transformational for Texas A&M and what that would mean for recruiting faculty and recruiting guest lecturers and students that wouldn't otherwise think they would go to A&M, can't get home. Where are my Aggies in the crowd? All right. Me too. Imagine starting your tailgate party in Dallas and not having to drive. Just saying. So it will be transformational for that whole region, the Brazos Valley. And then in Houston, like many places, a traditional old mall is really struggling or non-existent anymore. Well, the station location in Houston is the old Northwest Mall. And I was there just this week driving around it, and it's surrounded by light industrial, and it really is an opportunity to take a old dead mall and do something special with it. Because what will happen is you'll have retail and restaurants and living, multifamily probably. You'll have offices and all of that in a walkable sense of place. Right now, the tax contribution from that area is next to nothing. This will create that next place. And you're very conveniently located to Galleria, to downtown, the energy corridor, and the medical center. And we're right in the sweet spot of all of those. And the Metro Northwest Transit Center is right there. And they're doing BRT Galleria, and they're just had their bond election pass overwhelmingly. What does that mean about how you get from that area of town to downtown? They're looking at that and going to try to solve that problem that they've been struggling with for so long. So the things that will happen around the station with transit-oriented development, we've seen time and time again, will definitely happen in the project as well.
Very good. Paul, let's on some technology here and tell us about what's new with this N7005 that's going to be coming out.
The N700S, S for Supreme.
S for sexy.
Yeah. So it's an evolution of the N700 and the N700A. They've resculpted, it's had a bit of plastic surgery on the nose, so it's got a sculpted nose, and they've lowered the drag coefficient, and they've used a new material to smoothen it. And what that's done is increase the performance, both acceleration and braking. I'm going to get technical now, so for those in the room who are technical, this is good for you, everyone else. I apologize in advance. There are traction motors, so the original 700A had 4-pole, 4-magnet traction motors. These are 6-pole, and what that's enabled them to do is to reduce the size and weight of the train. It's about 150 pounds per motor lighter. And with that change, they've been able to add more batteries. So this train does have a small element of self-propulsion. It's a bit like a kind of a hybrid car. If we were to lose power out of the main line, we can move the train to a refuge track or somewhere to detrain passengers. I mean, this wouldn't necessarily be a failure of our system, but maybe a utility problem or a power problem. They've gained a lot of experience last 20 years. The N700 original version went into R&D in the early 90s. So there's, this is the best of what Japan has to offer. And like I said, it goes into service in July. I have been lucky enough to be on the train a couple of times. She is beautiful. It's a lovely train.
Yeah,
I guess one question, and this is a question for you, Holly, it's a question we've all been talking about. It's not up to me. I mean, I'm in charge of the technical specifications, but we still need to think about color, branding.
I have some ideas. It will not be orange. Yeah,
Okay.
to jump on what Paul was saying, all of those things that are enhancements on the technical side of the train translate into benefits for us riders. The fact that it's more aerodynamic means it's using less energy, which is better for our air quality. It's very smooth. It's very quiet. And all of those modifications mean that it gives you an even more exceptional ride. When there are seat belts. There's not only not any middle seats or seat belts. So walking around the train is just really comfortable and even better than most of the experiences that you would have on having that in European trains. And we talked about safety and time performance and things of that nature. The fact that the safety and the efficiencies of this train really just benefit all of us. It's kind of like getting a new iPhone. It's faster, it's cooler, it's a better next generation train, and I think we're very lucky to be able to bring that to Texas.
You don't have to put your phone in airplane mode.
Absolutely not. I like to joke with the engineers and with lawyers that if you can't do billable hours in that hour and a half,
You're not doing
somebody
it.
teach you right.
Paul, we're very familiar with the throes and probably the woes of PTC here as railroads try to wrap everything up in time to meet a deadline. You're going to be using a specialized form of ATC, right?
Yeah, so it's a bit of a complex topic, really. I mean, ATC in a sense is like a type of PTC. I guess the difference is, particularly in the American version of PTC, we're not so much of an overlay system, we're not so much of a system that's being added to an existing railway and then has to be made to work with that railway. The ATC in Japan was entirely central to their safety principle. So the train design, even the power substation design, the OCS design, are cognizant of that ATC design, the placement of the track circuit, placement of the transponders, of the protection loops, and it's fitted across the whole of the main line, and it provides this continuous, protection, position, and protection of all train sets. There are many similar systems in the world. I mean, this type of brake-calculated curve stopping point ATC is kind of, even in America, is quite common on light rail and and on transit systems, less common on heavy rail systems. I think the big difference, the Japanese system, this is from my experience, is the redundancy. I mean, there are lots of redundant systems out there. The Japanese system is dual redundancy times 2. So if you've got in simple terms, two computers are kind of continuously checking and acting upon data they receive, whether that's from the train to the wayside or from the wayside to the train, and these two computers of course agree. But if they do fail at any point, there's another pair of computers who are doing the same job as the original two and are ready to take over seamlessly. And this, I mean, redundancy approach is common in rail in the US as well, but it's two of two times two. Some would say engineering overkill, but what it enables us to do, this is the important point to me, is it enables you, I mean, it's the reason why Shinkansen's so safe. And it's not that Shinkansen's got some magical safety fairy dust or the Japanese have been lucky. You know, they've designed the system in such a way that the need to go from an ATC mode into a degraded mode is so infrequently used that they stay protected all the time. So there are some systems which are single systems or dual redundant. You may have to go into degraded modes. And what you're doing in a degraded mode is you're effectively handing over the movement protection of the train solely to the control of the train operator or the driver or the engineer. And the Japanese ATC is so redundant that you can lose significant portions of it, and it completely maintains and continues normal operation. I mean, one of the experience, I stayed in Taiwan for the first 2 years of operation, and we had no double failures in Taiwan during those 2 years. 6 years after opening the railway, there was a double failure, and by that I mean both the protection systems failed. There was a double failure. The train came to a stop safely, and they took the train into the station and took the passengers off and switched out a new train. For that to happen once only in 6 years, when you compare that to protection systems on other transit systems or railways, it's incredible. And subsequent to that double failure, it's never happened again. So they've really only had in service a single dual failure. It felt safe, they offloaded the passengers, they put in a replacement train. I mean, there are not systems, and I've worked on lots of systems, both Asian, European, Japanese, Chinese, American. There is not other systems which can be compared to it because of the redundancy.
Holly, as you think about the future of the Texas train and its impact it's going to have on us, how do you believe, is this going to change the way we travel in Texas?
Well, I really think that, well, let me back up and say nobody can argue that Texas is growing at an exponential pace. Everybody is looking to see what we're doing here. But yet when you travel internationally, oftentimes people think we still ride horses. So having the very first high-speed train in the United States in Texas is a bit of a head scratch to many on the international stage. So I think first and foremost, it will have people looking at Texas differently and wanting to understand what we're doing here, how it happened here, why it happened here. I also 100% believe that it will transform how the greater Houston area and North Texas relate to one another. And that, I think, will have people thinking about distance and time differently.
Paul, most people have never traveled on a Shinkansen. Probably the closest we've ever gotten here is if you go over to the UK, maybe, to go by the TG in France, maybe some other country if you've gone over on a vacation or on business. Over here, it's the assembly between New York and Boston. So give us kind of an idea of the...
When I was a kid, I was like 9 years old, my dad had a 950cc two-door Mini. And I was so scared of it that every time we got to a junction on the road, it used to honk out, and I was sort of concerned. And then a few years later, when I was about 11, I went to a wedding, my uncle's wedding, and I got to ride in a Rolls Royce. And magical to me. I mean, it didn't sound like it had an engine. It was gliding along the ground, and it was like being on a magic carpet. And that's the difference. If it's something I can sort of put into words, it's that different. Sometimes on Shinkansen, when you're working or reading a book or listening to music or watching TV or whatever you're doing, you forget you're on a train. And it's incredible. And I was on Shinkansen about 2 weeks ago. I traveled from Hamamatsu to Tokyo. I built the train depot down there to look at some maintenance equipment. And I'm still like a little kid with this wonder and excitement. I get on the train and I look out the window. I mean, the only thing that we don't have in Texas is Mount Fuji out the window. If someone could build a big snow mountain, that would be great. So I think it'll be, I think it's going to be amazing. The other thing is, I mean, we're working hard to put the best high-speed internet on the train. We're going to give people connectivity right through the alignment using a brand new system that the Japanese, it's a European system but with Japanese experience. So, the way I think of internet now is it's a bit like a basic human right. I mean, people want water, they want oxygen, they want internet. And so I think we have to get it right. We have to get communication right. If people are going to work and use this train, I want people to video conference on the train. I want people to video stream the train. I want people to get on the train and after a few years feel like it will make Houston and Dallas feel like almost, it's maybe a wrong thing for me to say, but almost a part of the same city. And I still get excited when I go on Shinkansen, and I've been on a lot of Shinkansen lately.
So
Hold on, real quickly. How many of you have ridden on the Shinkansen? Okay, if you don't believe what we're saying, go find some of these folks and ask them for yourself.
So the only question I want to know is when I've got my Shiner Bock beer and I'm sitting down at the seat, there's going to be barely a ripple.
Yeah, I mean, we're building the alignment as straight as we can, as flat as we can, which is kind of different from Tokyo because that line, the original 1964 Tokaido line, wasn't built with 300 kilometers or 330 kilometers in mind. They've had to put in vertical stabilizers on the train. They've had to build in new techniques for going around bends. We don't have those problems. We're going to be like the straightest, flattest rail that we can build. And that's what makes the difference. It's not just about the train technology. It's about construction methodology. It's about the rail flatness. It's about the curve and everything else. And, looking at our alignment, it's about as straight as we can make it. So I am extremely excited. Like I said, nobody had to twist my arm to come here to do this job.
Yeah, if you actually look on the internet and you look for Shinkansen coin challenge, you can see somebody bouncing a coin on its edge. Trains going 200 miles an hour, a train going the other direction 200 miles an hour, coin fall over. Wow. And we had Brian Curtis was over in Japan and rode the train, and he just did a recent program on the accomplishments that we have, and the idea of his report in November was nobody has any idea how far along you are. I want to tell that story, and he did. But years ago, he went over there and rode the train, and he put his water bottle on the windowsill.
Yeah, I saw that.
And it was just flat. And he's looking at it, and Pan Central guys weren't too thrilled that he put it on air, but it was there's nothing that can explain it better than you're not going to spill your glass of wine or your coffee.
Well, Holly, I'm going to leave you with a final word for today's conversation here. What do you want to leave our audience with, knowing about the project, and where do we go from here?
Well, first and foremost, thank you. Thank you for all of your advocacy. Thank you for your support. We wouldn't be able to do what we're doing without your voices. Although we're not a government project, we're highly regulated, and we need support of the elected officials that you heard from even earlier today. And I would say a big thank you to both Celia Israel and Matt Krause as well, if they were here, because they're both very strong proponents. The governor actually was in Japan last year and rode the new train that will be deployed here, and I think he was positively impressed. But your voices in the interim and during the legislative session and with regulators matter. They view us as being paid to say it, but you saying it really does make a difference. So first of all, thank you. We need your continued support. Also, I just give a shout out to our other Texas Central team members who are here, Travis and Liz and David and Rebecca. If you can't find Paul, we'll have folks around. We are very committed not only to doing this, but doing it the right way and making you proud so that it can be replicated in other places. So thank you very much.
Holly, Paul, thank you very much. Give them a hand, please.